So either way, we already have our coffee. Hopefully, you already have yours or whatever drink, yerba or tea. It's up to you. Uh, we want to captivate 15 minutes of your time, tell you a few interesting things from telco business, a few topics that, from our point of view, are quite hot topics right now in the industry. So please join us, spend these 15 minutes with us, and if you find it interesting, just let us know. We'll be happy to answer any of your questions. Let's go.
Let's
go.
start it.
So guys, regarding 100G standard, at the beginning there were at least few form factors that were fighting for the primary spot. Actually, I think we can already say that QSFP2080 is the king of the standard, and especially 10 kilometer and 20 kilometer distances are already like the standard ones. But the question is how it is with the 40 kilometer or longer distances. How do we cope with 100G connections for these distances?
The most simple solution in this area is QSFP 28 100G transceiver ER4, which give us the opportunity to transfer the data on a distance up to 40 kilometers. It could be single rate transceiver supporting only Ethernet standard, but it could be also dual rate module having functionality of OTU for transmission. So as I said, the most simple solution is just offhand ready transceiver giving us opportunity to realize the transmission for distance up to 40 kilometers.
If we're talking about a bit longer distance, then we could play with ZR4. ZR4 transceiver are able to carry the data for the distance up to 80 kilometers. And the most important parameter of this transceiver is the power budget, because we need to remember that 100G transceiver works in O band, and O band is the second transmission window, so the insertion loss there is a bit higher. So we are talking about the power budget around 28-30 dB to allow us to get the distance around 80 kilometers.
So how does it play with the MSA standard? Does the standard include the requirements of the current applications of ER4 and ZR4? Because like MSA was created several years ago, and is it still up to date with the current solutions?
Yeah, you are right. Standard is quite old, and according to transceivers for longer distances, the most important issue related to the standard is the power consumption of such transceivers. And at the beginning, the standardized power consumption included in MSA standard for QSFP28 was not enough for power consumption we have with these longer distance transceivers, and it was changed in 2019. It was updated with the new power classes, including power consumption even up to 10 watts. So now we are prepared for this, and in case of mentioned ZR4 transceiver, we are talking about power consumption around 6 watts.
But I think that worth to mention is that updating the standards, the papers, do not update the devices we already have. So if we have the devices which were constructed and deployed based on the previous standard, we still could have issue with the power dissipation they are able to accept per single port. So this is something which still need to be strongly considered.
So the transceivers that we were talking about, like ER4, ZR4, so compared to the shorter distance transceivers, is there like the hardware difference?
The main difference comes in how the transceiver is set up. So to be able to reach the distance 40 or 80 kilometer, the key parameter is integrate small micro semiconductor optical amplifier on the receiver path. Only this way we could really achieve the needed power budget to be able to realize to deploy the long distance transmission.
Second difference is laser used in transmitter. For longer distances, in general, it has to be EML laser, electroabsorption modulated laser. In opposite to the DML, direct modulated laser, used in let's say more simple transceivers for shorter distances.
So what are the possibilities of the semiconductor optical amplifiers? So we can actually use the standard laser with the SOA to reach this distance that we require?
This is the tricky point, because EML laser generate, saying it in the simple words, a bit more clear signal. So when we use semiconductor optical amplifier together with EML laser, then we are able to reach longer distances. With DML, we still could use the semiconductor optical amplifier, but performance we will get will be much lower. So what we check in our laboratory is roughly about 30-40 kilometers, even with really powerful semiconductor optical amplifier.
Okay, so to sum up, to build the links over 40 kilometers, 100 G links, we can use either ER4, ZR4, or LR4 with semiconductor optical amplifiers built in or added to the system on our optical path, right?
Exactly.
So guys, recently I had a call from the customer. So he says that he had the crew, the installation crew, going to the site to install another node of their network. And actually on site, it appeared that they had a huge problem because they had the new vendor equipment that they purchased because of the problems with the availability of their previous vendor of the active equipment, and it appeared that the storage guys provided them with the incompatible transceivers. So actually the whole installation crew needed to come back to the warehouse to take another part of the transceivers. They lost a lot of time, they lost the maintenance slot, and they needed to do the same job actually almost twice. So he asked me the question, is there a way to do it differently? Maybe they could omit such problems using some kind of solution. What do you think?
This idea, such a goal to provide the universal transceiver independent of the network device you would like to plug in to the device, was actually foundation of our project and development of SRD device and environment. because we developed the SRD device just for somebody who need to install the transceiver in network device met on the location when that installation is planned, and that person should not worry about the compatibility of the transceiver he taken from the warehouse, because our idea is to provide the solution for programming this compatibility at the moment of installation. Nobody have to take care about the type of the transceiver or brand of the transceiver at the at the stage of planning such installation.
So, what actually is SRD?
SRD is the device. We originally called this device simple recode device. The main idea of developing such device was to develop the device which allow the user to change the compatibility with few clicks. So basically you insert the transceiver into the device and you choose from the drop-down list the vendor to which the compatibility of transceiver needs to be changed. But when we look a bit deeper in the whole environment, this device in fact allows us to change the way of thinking of third-party transceiver. Because originally the third-party transceiver was supplied to the operator, to the ISPs, as a device, as a component, which need to be compatible with particular vendor. So in fact, what we do, we replace the original transceiver with third-party compatible transceiver. But the idea of SRD device, idea of universal optical transceiver, allow us to change the way of thinking of this, because instead of keeping the stock for 2 or 3 different vendor, let's say SFP plus LR transceiver, we could keep just one. Instead of ordering 3 different transceiver, we could order just one. So also the warehouse guys, when they give the transceiver to the field engineer, they also just give them the same transceiver. And the engineer on site, when doing the deployment, he makes the decision which vendor the transceiver needs to be compatible with. So he plugged the transceiver, changed the compatibility and install. It's definitely the huge simplification of the process of ordering, maintenance, and keeping the transceiver on stock.
Coming back to the problem you described at the beginning, in this idea there is no place for such a mistake, because doesn't matter. The only one important thing is to take care about taking proper type of transceiver from the warehouse, because compatibility with certain network device met by the technician at the location of installation could be programmed by few clicks at the moment, just before the plugging the transceiver to the port of the switch or router.
So actually, if the installation crew had the SRD with them, they wouldn't need to come back to the warehouse, lose the day and the maintenance slot, and actually money at
Sure.
the end. Some time ago, when we were talking about the coherent transceivers, it was said that using them will simplify the network design. Does it really look like this?
Using the coherent transceiver itself, maybe not, but the new optics, the QSFP-DD DWDM coherent optics, which allow us to take this path, to go this path. because QSFP-DD could be installed directly into the network equipment. So when the coherent transceiver with all the idea of the OTN transport will be installed directly in the network device, we could basically we will not need transponders. If we don't need transponder, it means that we could also skip the gray optics to build the connections between the network devices and transport devices. This make our network much more simple. And what else we benefit with such a network concept, with such network idea? We also reduce the space in the rack we need. We reduce the power consumption, and this is the huge benefits of the installing the DWDM transceiver directly into the network equipment. Also, by reducing the number of active equipment, we are able to lower the value of the delay between points because we have less system regeneration.
It is possible thanks to the new standards, because in older generation of coherent optics, we have not so simple situation. There was a lot of incompatibility between vendors, and QSFP-DD standard and CMIS related to this kind of transceivers made the situation much easier and clear, and we can really talk about standardization and unification of such solutions. And thanks to this standardization, we can really connect or establish coherent transmission between transceivers and equipment from the offer of different vendors. Generally, we have two standards for coherent QSFP-DD optics. One is developed by OIF organization, and it is OIF 400ZR standard, which is mainly dedicated for transmission inside and between data centers. Those transceivers support Ethernet transmission on the distance up to 120 kilometers. Use one error correction algorithm CFEC, and use one type of modulation 16 QAM. And the second standard is MSA OpenZR Plus. It is standard for coherent transceiver supporting not only Ethernet transmission but also OTN for transmission, and within this standard transceivers could support much more modes of work. I mean different transmission speed, different error correction algorithms, and different kind of modulation. Thanks to that, we can reach the very good transmission standards even on the transmission lines with very low OSNR.
So how about in terms of distance? What are the maximum distances we can reach?
The maximum distance, of course, will depend on the network quality. And one of the factors we could measure the network quality is optical to signal noise ratio. And for 400ZR, standardized by OIF, the one who is responsible for the data center interconnection, here we are talking about 24 dB. But if we go to the MSA standard, which also introduce more operation mode. So from the host point of view, such kind of transceiver could support 400 gigabit Ethernet, could support few 100 gigabit Ethernet transmission or few OTU4. So with depends how much data we will carry on the line side, we could reach the different distance, because modulation in the MSA standard transceiver could be changed from QPSK up to 16 QAM. So with 16 QAM and the OFEC correction methods, we are able to reach up to 22 dB in terms of the SNR parameter. But if you go to QPSK and 100 gigabit line speed, we are able to get the working path even with SNR on the level around 10 dB. So talking about the distance, 10 dB, it could be even few thousand kilometers. 22 dB, it's around 500, 600 kilometers. So the distance we are able to reach now using the 200G coherent optics from the previous generation. So it's pretty impressive.
So actually, we can reach really long distances. We can build the actual long haul connections without transponders, with the transceivers installed directly in routers or switches, right?
Exactly.